Hello, this is Mrs. Ross, and this is Lesson 53, Starred Problems. If you're looking for the practice set, that's going to be in a previous video. Lesson 53 starts on page 376 of your Saxon Course 2 textbook. Let's go ahead and get started. Okay, so these are practice set problems I did in a previous video, and here's our first starred problem. It says write 1 trillion in scientific notation, and then also write 475,000 in scientific notation. Remember that scientific notation has a number that is between 1 and 9, a decimal point, and then it can have as many places behind it. You can have 1 place, 2 places, 10 places, it doesn't really much matter. Times 10 to the something. So this is just kind of the format of scientific notation. So let me write out 1 trillion. So let's see, 1,000 million, billion, and now we have trillion. So I know that I'm going to have, let me go ahead and change colors here. So I know it's going to be 1.0. I really don't need this part here. So we have 1.0 times 10 to the something. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it's going to be 1.0 times 10 to the 12th. Okay. And then here I'm going to put my decimal point right behind the first number that's not 0. Oops. Which is 4. So I have 4.75. I want to keep all of the non-zero numbers. And if there's 0 between numbers, I need to keep that one too. I don't have to keep these other zeros. So this is 4.75 times 10 to the 1, 2, 3, 4, 5. That's how many places I had to go to put that decimal point there. So this is 4.75 times 10 to the 5th. Okay. Number 7. It says write 7 times 10 squared in standard form. So that's 7 times 10 times 10, which is 7 times 100, which is 700. Or you could take this and just add 2 zeros there, since there's nothing else behind the 7. And here you have 2.5 times 10 to the 6th and 2.5 times 10 to the 5th. So this is the same. However, this is 1 larger. So that's going to be the larger one. You can always write these out in standard form if that helps. Let's see. All right, number 8 says use unit multipliers to perform the following conversions. So it says 35 yards to feet and gives me the 3 feet is equal to 1 yard. You can also write that as 1 yard is equal to 3 feet. And we're going to use our given times the unit multiplier is equal to the answer. We're given 35 yards. I know I need a unit multiplier in there. It's going to be one of these two fractions. My answer needs to be in feet, so I know I need feet here on the top, which means I'm going to use this unit multiplier. So 3 feet, 1 yard. My yards cancel. I get 35 times 3, which is 105 feet. And that's my answer. Let me go ahead and grab a different color. Here I have 2,000 centimeters to meters. And I have 100 centimeters is equal to 1 meter. You can also do it with 1 meter over 100 centimeters. Using the given times the unit multiplier equals the answer. I'm given 2,000 centimeters. My unit multiplier is going to go right here in fraction form. I'm not sure what it's going to be yet. And I'm converting to meters. So I know that this needs to be meters in the top. So I'm going to grab this one. 1 meter is 100 centimeters. My centimeters cancel. I end up with 2,000 as I multiply across the top over 100. And then when I reduce, I get 20 meters. All right. This is not a starred problem, but we're going to do it anyway. It says a car traveling at 62 miles per hour. Hold on just a minute. That's 62 miles, the per line, an hour, is moving at a speed of how many kilometers per hour? So the only thing I want to change is this. The per hour is going to just stay the same. And here is 1 kilometer is equal to approximately 0.62 miles. So let's use our given times our unit multiplier, which is right here, is equal to our answer. We are given 62 miles, the per line hour. Okay, we have a unit multiplier that we need, but we're not sure what it's going to be, and this needs to be kilometers per hour. So we know hours isn't changing. I want kilometers in the top, so I have 1 kilometer is equal to 0.62 miles, so my miles can cancel. Kilometers per hour is exactly what I want. I end up with 62 times 1, which is 62, and then 1 times 0.62. So I'm going to divide these. 62 divided by 0.62 is 100. 100 kilometers per hour. All right, in the school marching band, the ratio of trumpet players to drummers is 5:2. This word right here means I'm going to need a ratio box. So let me get another color. Let me do my ratio box. This is the Dora the Explorer method. Ratio box, proportion, cross multiply. So my ratio box, here's ratio, actual, and what is my ratio of trumpet players to drummers? So I'm going to use T for trumpet and D for drums, is 5:2. If there were 6 actual drummers, 6 drummers, how many trumpet players? So I have my ratio box. I'm going to make my proportion from here. And then I'm going to cross multiply. So let's see if I cross multiply here. I have 2 times x, bring my equals down, cross multiply here. 5 times 6, so I have 2x is equal to 30. I'm going to divide x equals 15. All right, so now we're going to add these and then we'll simplify it. So I have 7.5 plus 6.5. So 1 plus 1 is 2 over 2. This is in inches. 7 plus 6 is 13. And then I have 3 feet and 3 yards. So let me take care of this business here. I'm going to change colors. I'm not changing anything with the yards. I'm not changing anything with the feet. This actually gives me 14 inches, right? 2 over 2 gives me another inch. And I know that there are 12 inches in a foot. So let me go ahead and take away 12 inches. So I have 2 inches, but when I do that, I have to add the foot here, 4 feet, and I've done nothing to 3 yards. Now I know that there are 3 feet in every yard. My 2 inches is fine. It just comes down. I'm going to subtract my feet and add my yard. So I have 4 yards, 1 foot, 2 inches. That is my answer. Okay. Here I have a list of numbers I'm adding. And the only thing that is different here is that this is 10 to the 1, which means that I'm going to, if I were going to write this in standard notation, this would be 38.75. So all of the other numbers are fine. You would just plug those into your calculator. Let's see. 10.6 plus 4.2 plus 16.4 plus 38.75, and I get 69.95. Let me know if you get something different. It's always, I could always be making a mistake. You need to call me on those if you see them. Find the value of A times B divided by B times C if A is 6, B is 0.9, and C is 5. Okay, so AB, B, C. A is 6, B is 0.9, so I'm just plugging in what we have, divided by B is 0.9, and C is 5. Okay, so what's 6 times 0.9? I get 5.4, and 0.9 times 5, 4.5, and now I'm going to divide. 5.4 divided by 4.5 is 1.2, and that's going to be your answer for 27. Let's change colors. Peterson needed to pack 1,000 eggs into flats that held 2.5 dozen. Remember, this is 12 eggs. How many flats could he fill? So one flat is equal to 2.5 dozen, which is, let's see, 12 times 2.5 is 30 eggs per flat. So now that is an L, fatat? I don't know. So now let's see. If I divide this by 30, well, it's not going to go in evenly. I get 33.3 repeating. So he's going to fill 33 flats. There's going to be, if he needs to ship all of the 1,000, he's going to need 34 total flats. That last one is not going to be filled. But it says how many could he fill, so this is your answer. Oh, and that's it. Okay, let me know if you have any questions. Have a great day.